present is software, RockSim. And hopefully everything will run right. And you'll all enjoy it.
All right, thank you, Bob. Good morning, everybody. My name is Tim Van Milligan. I run Apogee. We've been selling RockSim now for well over 10 years. Let me get a show of hands. How many people are already using RockSim? Okay, more than half. And everybody else, have you ever seen it before? What I plan to do on this one, I told Pat that I wanted to do this, making this a beginner RockSim for people who've never done RockSim before. But I can modify that and do some things that for people that have used RockSim before. I can show you some more of the advanced things too. The kind of history of RockSim was probably, I'm trying to think of the year. It was probably about 1996. I got an email from a guy named Paul Fossey who wrote the program. He sent me an email. He got my book. Anybody seen my book, Model Rocket Design and Construction? He got that book and he says, "Hey, I want to work with you and make a program to design rockets." And I didn't think anything of it. So because I get these kind of things all the time. People call me up and say, "I'd like to do this or that," and most of the time it never pans out. So I just my philosophy is let them run with it and then see what happens. Well, he came back and what he showed me was just incredible because at the time there was nothing that could do. Basically what he was doing was, instead of doing a simulation software, he was doing a design software that calculated the weight of the part, which nobody had ever done before. So that was kind of cool. So from that, I worked with him. I fed him equations out of, equations that weren't in the book on how to calculate the trajectory of the rocket. And then him and I, we worked together to create the user interface. And then over the years, we've grown it. We're on version 9 now. Version 9 is kind of old already in computer years. It's about 4 years old, so it's getting, we're waiting for the next version. And I don't know when there's going to be a next version. I know as soon as version 9 was done, he started on version 10. But in the meantime, we went from Windows XP to Windows ME to Windows Vista. So when version 9 first came out, Vista wasn't out yet. So we've had to upgrade it for Vista, then Windows 7, Windows 8. We've also had to upgrade it for Apple version 10.4, 10.5, 10.6, now on 10.7 and 10.8. And every time one of the software makers, or Microsoft or Apple releases something, it breaks RockSim because they move everything around, and so we have to. And that's really the holdup in the development of the next version is they keep changing things faster than we can fix them. So I'm going to sit down, and this is the basic screen you get when you open up RockSim for the first time. Up along here are the button bars, and you'll see me use these. What I recommend people do when they first start RockSim is open an existing design. You just go to File, Open, and it brings up the design folder. This is one of the things that we had to fix is Microsoft didn't like where we had our design folder. So we had to point it to the right direction. So these are designs that are already in RockSim, and you can find other designs on the internet. One of the websites is rocketreviews.com. They have probably hundreds of different RockSim files that you can open up. And manufacturers, are there any kit manufacturers in here? No. There are a lot of kit manufacturers. We give them the software. We say, create your own database because we don't want to be the creator of the databases. So you can open up a design. Let's see if I can find a simple one. The Avion. All of our rockets end in .rkt. That's our file format. And just click open. Okay, so then it brings up the rocket down here in the bottom, and we're seeing a 3D view. I can change it to a side view right here. So this is a side view. And if you want to make it bigger, you just double click on this bar right here in the middle. So now it detaches the image from the main menu, and I can see a picture of the rocket. On the rocket, we have the center of gravity of the rocket and then the center of pressure. And for a rocket to be stable, where does the center of gravity have to be? Forward. So the center of gravity right now, it is forward, and it's telling us our margin. The margin is the distance between the center of gravity and the center of pressure divided by the body tube diameter. So it tells us it's 3.91 body tube diameters in front. And in general, we want a rocket to fly with at least one body tube diameter in front. And that's because there's always a little bit of uncertainty where the actual center of pressure is. And by at least having it one body tube diameter, we have that stability. So that is how you do that. And then to get it back down, you double click on the bar again, and it throws it back down the bottom.
Jim, do you want us to save questions for the end?
You can fire them at us, as we go along. You got one?
Real quick, when you have various fin designs, and because of your uncertainty with the center pressure calculation, as you said, how well do you think right now is it all empirically based, or calculating the coefficient of drag relative to various fin designs and thickness?
That's not a coefficient. I was talking center of pressure. Now you're talking coefficient of drag.
Right, but your coefficient of pressure is strongly going to be affected by the amount of surface area of your fins.
Yeah.
It's going to shift it.
RockSim assumes it's a flat plate, so when you go in thickness, it's not going to see that thickness.
Okay.
So that's a good point. That's why one of the things you want to do is make sure that there is some stability margin in there. To load a rocket engine, and this is what I suggest you do, the second thing after opening the design is to throw a rocket motor in here. You'll go to this icon up here. Basically, this is like the rocket sitting on a pad. So there's the bottom of the rocket. Here's the blast deflector. So that would be prepare for launch. And that brings up this simulations property screen. You'll see RockSim sees that there's an 18 millimeter motor mount here, but it doesn't have an engine in it. So you just click on the choose the engine button, and it brings up a list of all the engines. Right now it's filtering it by only the engines that will fit this motor mount diameter. So I'll just select one, an A8 motor, and then you can change the delay down here. And this shows all the different delays. Now, a none is basically a plugged motor. So if you're doing a high power motor, it's going to be none, and that might be your only choice. Or all. All is basically, when we first developed RockSim, people wanted to see the trajectory, and they wanted to know where along that trajectory each delay would occur. And so when you do an all, basically what it does is we can bring up a screen later showing the altitude versus time, and it will show where each of those delays happen. And it can kind of confuse people, so eventually I think what we're going to do is we're going to delete all, because it causes more confusion than it helps solve, because people don't really care anymore, it seems like. So I'll just pick a 3-second delay and then click OK. There we go. Okay, so now the engine is loaded. You see the icon here on the back. Before it was empty, now it's got a motor in there. And up along here on the top, these are the other things that we can change. A flight event is anything that can happen in the rocket, like staging or parachute or streamer deployment. Right now we have it deploying at maximum ejection delay. So we selected 3-second delay. So the maximum ejection delay is 3 seconds. So 3 seconds after burnout is when it will deploy. If you want to do dual deploy or anything like that, you can set it to deploy at a time after ignition or time after apogee. Deploy at apogee, or deploy at a specific altitude. For most small rockets, you just leave it at deploy at maximum ejection delay. Under simulations controls, I would just leave this alone. I never really changed this one at all, but you can change your simulation resolution. The higher the resolution, the better the accuracy, but it doesn't get too much better. So 800 samples per second is pretty good. Starting state, this is our angle and the launch angle and our launch guide length. So if you're using an 8-foot rod, you would change the launch guide length. Right now we're at a 36-inch for a small rocket. Launch angle, you can either type in a number here, and hit tab, or you can also just take this slider bar here and change the angle.
When you type in 45, some NAR warning doesn't come up.
The beauty of this is you can try all those crazy things in the software without doing it on the field. NAR rules, of course, say what?
30 degrees.
30 degrees from vertical. So anything greater than 30 degrees, you're violating the NAR safety code. You can go negative or positive angles. Right now, RockSim is set up for the wind coming from the left. So if you're going, the wind would be going this direction. So if you're angling this way, you're going into the wind. If you angle it the other way, you're going with the wind. We'll go just straight up for the first launch. Whenever you type in a number, hit the tab key, and that will force it to accept the number. Okay, so always hit the tab key. Launch conditions. This is our weather conditions. Right now we're launching at sea level, which here in Florida is pretty good. In Colorado, our launch field is 4,700 feet, so we have that advantage of going higher there. This is standard atmosphere, 59 degrees Fahrenheit, 1 bar. If you like it in inches of mercury, just select inches of mercury down here, HG mercury. So now we're at 29 inches of mercury. Wind conditions are calm. You have a lot of choices here. No wind, obviously it's perfect conditions. Cloud coverage, this controls, all this down here controls the wind. Over here controls thermals. I usually turn this off. If you really want to see what it's going to do in thermals, you can turn it on, but you can't really predict the thermal. So I just turn it off, say no thermals. And basically then it ignores everything on this column. Competition settings, I rarely turn this on. This is for people that want to do competitions against other people on the computer. But it's not really realistic. It just, basically what it does is it throws randomness with these variables right here. But when you're doing your simulations, most of the time you don't want randomness, you want consistency. So that's why I just turn them off, and just turn them off, just don't check them. Okay. So right now I'm running with these launch conditions, no wind, straight up, and I can either choose launch or flight profile, and I typically just choose flight profile because then it will bring up the trajectory of the rocket. So just click on it, RockSim runs its simulation. When it's done, it shows you this screen, and it's basically just a random image of a launch field. Here's the rocket down here. It's pointed straight up. When you click the start button, the rocket will take off. You see this down here is smoke. That was during the thrust phase, and then it was coasting. The parachute popped out at the right time, and now it's just drifting down. And since there's no wind, it's going to launch. It's going to land exactly on the launch pad. If you want to speed things up, you can grab the slider bar here, and you can see anywhere in the flight time, and it will tell you the range and the altitude of the flight. And then when you're done, you click cancel, and then it brings you back to this screen, and it will show you the one that it's highlighting is the last simulation that you ran. So there were some previous simulations here that were shown that were saved with the design. And if you want to move things around to see more information, you can, just like on any program, just move the columns over. There's a little arrow on the parachute, and that arrow tells you the direction of the rocket was going when the parachute popped out. So this one is pointed up, so the rocket was still going up when the parachute popped out, which tells us what?
Delay's too
We
short.
need more delay. We need a longer delay. When it's pointing down like this first one, that means it went over the top and it's coming down. Ideally, you want it to be with no arrow. That means it's right at apogee or pretty close to apogee. But it's pretty hard to get. This will also tell us some information about the flight. Our maximum altitude on this motor was 333 feet. Maximum velocity, 164 feet per second. There's more information over here. Altitude at deployment, 329 feet. So basically, altitude at deployment was 329 feet, but the maximum altitude was 333 feet. So what was going on there? Basically, it was dragging the parachute up. It still had momentum, so it was dragging the parachute up. The next thing I recommend for people that are first getting into RockSim is now start changing things in the simulation. Because that's basically what you want to see anyway. So I'm going to leave the engine the same. I'll change the starting state. Now we'll angle the launch and do it again and see what happens. So now you see the rocket moved over, and now it's at an angle. It's pointing somewhere, and when we launch it, we'll get the rocket going over the top. Oop, again, it popped the parachute a little early, and now it just falls straight down because there's no wind. So our altitude, what happened to our altitude? The altitude went down because we're angling, which is what we expect, right? We'll then run another one. This time let's change some, add some wind. So this time I'll add a slight breeze, 18 to 14 miles an hour. Basically what it's doing, that 18 to 14, RockSim is going to vary it in there. Just like in real conditions, you don't know, you kind of sense that it's about 8 miles an hour, but sometimes a little gust might come along. So it will always be within that range. We'll launch it again. Again with the rockets pointing into the wind. We start it. You see now the wind over here is pushing the smoke. It's also pushing the rocket back. And you can see we landed 150 feet downrange. You can back it up and kind of do it in slow motion. As it comes off the pad, you see the rocket wiggling back and forth. Just in real life, like in real life, it's gonna wiggle a little bit. Would you consider this to be a good launch?
Okay, you got it back.
You got it back. It's always a good launch when you get it.
Well,
It's not on the weeds.
yeah, so it's good. You got it back and it comes back pretty close to the launch pad.
I would call this one pretty marginal. Like you did get it back, that's fine. Typically, we like to see the rockets go straight up. I don't have a dry erase here. Trip Barber came up with this really cool way to tell if it's a good launch. Basically, you think of a cone coming from vertical from the launch pad, a 30-degree cone. And if the rocket ejects somewhere within that 30-degree cone, that's pretty good because it's not weathercocking too much. If it ejects out of it, that means the rocket arced too much. And I really like that, and I'm trying to get the programmer to draw a cone in here so you can actually see it, which would be a really, really neat trick. So hopefully that will be in a future version.
So have you done studies comparing the simulator to what happened in real life and to see how accurate it is?
Well, it's a relative term, studies.
Yeah.
We've got
Or do you
all
get
these
do you get
people here.
feedback? I mean, do you get
Yeah,
feedback?
we get a lot of feedback. Yeah, you can say that. then there's the opposite feedback, which is why it's like because you can. There's a lot of variability
Sure.
in wind. If you can set it up pretty close, you'll get fairly close. the atmosphere is never perfect, and your rocket is never
Yeah,
perfect.
you got ground winds and high level winds, and they all change.
Yeah.
You know.
Different humidity.
But this gives you a starting point.
It
Okay,
is
so,
pretty good though, of the student group that talked about the summertime launch where Paul and I launched from down in West Palm. I've gone back and iterated a few times with the winds and thermals, because we have a lot of thermals down there. And we got to within about 10%, which when you're predicting it, you're going back and getting the same answer.
yeah.
That's not bad.
You always got to go out and test fly. Especially TARC teams, they want to use this as gospel truth, and you can't. You got to go out and test fly, because the big uncertainty, other than the weather conditions, is your coefficient of drag. And RockSim tries to get you in that ballpark, but it's not as perfect as we'd like. So you always have to go out there, fly the rocket, measure the altitude, and then come back here and adjust the coefficient of drag. And then you can get better results the next time. I wrote an article, it's on the Apogee website, how to back out the coefficient of drag from your altitude readings. And I was talking to Jonathan Rains last night, and he said he loved that article. It looked really good for him, because there was 3 different methods of backing out, depending on what kind of altitude you had. Okay, so now we've run a simple simulation, and at this point now you're wanting to design your own rocket. But before you do that, I would suggest taking an existing design and modifying it. So to do that, along here are the rocket design attributes. This gives you a little bit of information about the rocket. Right now, the name of it is the Avion. The calculation method is using the RockSim stability method. Everybody asks, what's the RockSim stability method? And basically, RockSim is the Barrowman equations. Everybody knows what the Barrowman equations are. When Jim Barrowman wrote the original Barrowman report, and you can actually download it from the Apogee website. It's in our technical publications area. If you look at the equations, he made these simplifying assumptions. Like the rocket is generally long and stable and the fins are at the back, things like that. Well, that works good for simple rockets, but back when he wrote it, people were still doing equations on slide rulers, and it was long and tedious. So he made a lot of simplifying assumptions. And what the RockSim method is, it's the Barrowman, it's those original equations without all the simplifications in them. So theoretically, it should be better. And people always ask, is it better? And I say, yes, it is, but trust if you don't trust it, then use just the original Barrowman equations. You can select those right here. Use the Barrowman equations. You can also use the cardboard cutout, but I wouldn't recommend that. That's really very conservative. Basically what it does is it moves your center pressure so far forward. Here, I'll show you. So right now you have the center pressure, it looks to be like right in front of the fins right here. We change that to the Barrowman. You see that it shifted forward a little bit. So basically it reduced the static margin. And if you choose the cardboard cutout, it should go even further forward. Oops. Oh, actually, on this one, it moved it back. But I wouldn't trust the cardboard cutout. We just put that in there for historical perspective. Just leave it at the RockSim stability method. Okay, and then you have your design attributes, or the RockSim design. Basically, these are the parts. RockSim defines the rocket as the sum of the parts. So any part you put in there is part of the rocket. And it always starts at the tip of the nose cone and works its way down. So we have the nose cone, body tube, and then you have all these internal components. These are inside the rocket. And they're attached to the body tube. So here's our fin set. And it's usually fun to mess with the fins because the fins control so much of the stability of the rocket. And again, it's showing me a 3D view of the rocket, and I'm going to switch it back to 2D for right now. So you can adjust the stability of the rocket by changing the fins, and the biggest one that affects it is its location. See, when I move it move the fins ahead of the center of gravity, all of a sudden now we're unstable. And we'll leave it like that, and we'll see what happens when we launch it. Because everybody always wants to put their fins forward, especially the kids. So here's our rocket again, and remember it was pointed into the wind. We launch it.
Is that an actual model of the instability, or does it just cartwheel when it's unstable?
It cartwheels because it's unstable. It's just, there's so much going on that we just flip it. But you notice what happens is our maximum altitude here is way low. And only go at 66 feet. So where the fins are really affects the rocket. So we can go back and change those.
That's just
Change the location.
that's what we want.
Tim, if you try to, it doesn't take into account any effect of sweep there, the Reynolds numbers is so low.
The corkscrew.
Well, yeah, we can go change that.
Or the actual surface area, because your weight's changing, right? If you change the physical size of the fin,
Right.
it's gonna
Yeah,
use your
two things happen when you change the fin shape. Is one is you're changing the weight of the part, so the center of gravity is going to change. And the other thing is you're changing the center of pressure location. So if I change the sweep angle, which is this one here, watch the red dot, which is our center of pressure. So now what's happening is the rocket's becoming more stable.
Yeah, because you're moving more of the surface
Yeah.
area to the rear.
Okay, so after you've done playing around, now you say, okay, I want to design my own rocket. So now let's create a new design, and you just click up here on the new button. And it's going to ask, do I want to save the old changes? And I'll say no. Okay, now it clears everything out. So now we have nothing. And then basically to design a rocket, you just start with the tabs and work across. So rocket name, we'll call it NARCON.
Hey Tim, while you're doing that,
Yeah.
you were working with a RockSim file from an actual kit.
Yeah.
Is there any kind of lockout so that you can't accidentally, when you're playing around with one of those, accidentally save changes to an existing design? So that when you go back and look at you want to go back and look at an Avion next year, you forget that you changed the fin size? Or?
Yeah, you can't lock yourself out. Basically,
Suffix on the name when you say it.
I would suggest when you open it, save it automatically. And
Do a save as, yeah.
And if you really screw it up, then you go back to the original where you got it from. You can come back to the Apogee website for our kits.
Yeah.
Because all of ours are there. It's a different manufacturer. Hopefully they have them on their website. Okay, so we have our rocket, and it's going to be a single-stage rocket. If you want to make it a two-stage rocket, you can go over here. And the static margin reference, remember I was telling you the distance, the static margin is the distance between the center of gravity and center of pressure divided by the body tube diameter. Well, you can change the divided by part. Sometimes it's the base of the nose cone, sometimes it's the maximum frontal area. So if your rocket has a tiny nose cone, then gets really big and then tiny again at the back, you could say use the maximum frontal diameter, and that's actually a better thing to do. But by definition, we just use the base of the nose cone. But if you want more accurate stability, then use the maximum frontal air.
If you have a payload section, does it count that as the whole payload section of nose cone? Does that count as like a nose cone complex?
No, then it use the maximum frontal diameter. And if you want to use a custom reference diameter, you can set it here. And then it'll ask you what the reference diameter is. So I'll go back to the nose cone. Okay, so now I'm ready to start adding parts. This right here is, remember all the icons, the center of gravity, center of pressure. If you have a really big rocket, sometimes they'll be just like little dots. And if you want to make them bigger so you can see them, just change the side view marker size. For high power rockets, I usually set it at 1 inch or larger. People that are just starting out, they never figure that out. Okay, so we have two components here. Our sustainer. The sustainer is always the top part of the rocket. the booster is always the bottom. So I start with the nose cone. You always start with the top and work down. And RockSim will always bring up a database of parts. So you can select what part, what kind of nose cone you want. Here's a plastic nose cone, 29 millimeters in diameter. That's one of our standard items. If you want to use an Estes nose cone, they're in the database. We are not the keeper of the databases either. People always ask us, are all the parts in there? And no. If you want to add parts, basically you just change the dimensions here on the screen, and then just go to database and then say save to database. So if you get a new nose cone comes out from Estes, you can create the nose cone and then just save it into the database. So right now it's an O-guide shape, and you can change the shape to parabolic. You can see that changing the shape changes that. There's different shapes you can select from. Elliptical will give us a more rounded area. Power series, all these down here are change the shape even more. And then you get more control on the shape of your nose cone. For most rockets, this one came out of the database, so I'll just leave it at that. You can change the base length. The base length, sometimes nose cones go cylindrical. So this one is a tangent O-guide, so it actually starts right here curving. But if it had a straight section, I'll make it 2 inches to exaggerate it. See how nice and straight it got. I always tell people, just go ahead and play around with the different things, because you can't really break it. Just get it through, learn it as you're playing with it. You can't break it. We get a lot of customers that think that you can, but you can't. Material, the material changes the density. The density changes with the material. So if you got a balsa nose cone, it's lighter density than a polystyrene nose cone. So you can change your nose cone shape or material here. I'll just leave it at polystyrene. Construction is hollow. The wall thickness is 0.03. And basically what that's going to do is change the mass of the part. Right now it's calculating the mass. Although right here it says the mass override is on. So basically it's telling me that RockSim is not calculating the mass. It was already saved into the part. So for RockSim to calculate it, uncheck this box right here. Now you'll see, now when I change things, if I change the wall thickness, you get 0.05, and you'll see this mass change here. If you want to change units, just click on the units and go into grams. The database is to save that part into the database. The shoulder controls the length of the shoulder and the diameter of the shoulder. Mass override, I showed you already. Color, by default everything is blue. If you want to change the color of your nose cone, you change it here. You have 2D color and a 3D color. Right now the 3D color is blue. I can always tell when somebody's new to RockSim, because they leave all their colors the same, everything's blue. And I always tell them to change the colors. That way I know they're changing things. So right now I got a purple nose cone. And if you go here to 3D, you'll see a purple nose cone. But I'm not seeing the back of the shoulder, and that's because there's another setting here that's turned on. I can turn that on, I can show you that. Click OK. If I go to under Edit, you go here to 3D rendering and render internal surfaces. It was turned on. I'll make it high resolution. I don't know why it's not showing me my back. Oh yeah, it is. I'm just not seeing it. There, everybody see the back, see the shoulder. Okay, so now I have my nose cone. The next part you would add is your body tube. You can see as the nose cone is highlighted, now it allows me to select different objects that I can attach to my nose cone. And it will only allow you to attach things that seem apparent. So like right now, it won't allow me to attach fins, but I can move the fins onto the nose cone later. So let's go add a body tube. This is a 29 millimeter tube, so I'm going to add a 29 millimeter body tube. Go back to 3D. When you're not on the main screen, and this isn't the main screen is back here. If you want to make the image bigger, you just move your cursor up and down until the changer turns into a equal sign with the arrows at top and bottom. Now I can expand it up. And that's just as big as I can make it. And then you can also move the image around by clicking. And if you click on the trackball, then it will follow my cursor around. So I can look at right at the tip of the nose cone, or I can swing it around and look in the back. And if you use the scroll wheel, you can scroll in, zoom in and out. I'll go back to 2D mode. And basically what it's telling me now is my rocket is unstable, which is fine because I don't have the fins on yet. My color, again, I'll change my colors. I'm going to purple body tube and maybe yellow in 3D mode. This way I can tell things apart. Now I can add my fins. And again, it always goes to the database first to look for fins. And typically, people want to add their own fin shapes, so cancel out of the database. And what RockSim does, though, is it throws up a generic fin for you. Just something there that you can start modifying. So basically, I had 3 fins. I could change it to anything between 1 and 8. So right now I'm at 4. You can change your root chord. I like to use the slider bars because it's quicker. So you're changing the root chord. It leaves the front end mounted to the tube and then adjusts the back end. So it's a little touchy, so what you can do is just put the cursor over the top of the slider bar and then just use the arrows on the keypad if you want to get a little finer control. Okay. Tip chord length, that will be the top of the fin. And again, you can change that. Sweep length and sweep angle are tied together. Some people like to measure the angle. Some people like to know how far back it is from where it attaches to the tube. So that's the sweep length, would be that distance there. Semi-span is the length off the tube it is. So you can see as I increase the diameter, I get these really big things. I'm bringing it back to a more normal size. And location I already showed you. I can bring it all the way up to here. Now it's measured from the front of the tube. So because the tube owns the fins. So if you want to put it onto the nose, now you can change the location here and just make it a negative number, -2 inches. And then it puts the fins onto the nose. And as soon as I move the slider bar, now it changes the shape of the bottom of the fin. So if you print it out, now it should match the shape of the nose cone. But I'll just move it back for right now. The material is balsa wood, and our thickness, so if I wanted to change it to plywood fins, you just find your plywood that you want. Change the thickness. It's an 1/8 inch right now, make it a 1/16 of an inch, 0.06.
So again, the thickness is only basically affecting the weight in this case.
Yeah. If you change the cross section, then it will change the coefficient of drag. So if you make it an airfoil, now you got the lowest coefficient of drag. And same with finish, surface finish.
But those are just generic terms that you can't specify a particular airfoil or a particular
Yes.
profile.
You can, yeah.
Can make it a spin fin.
No. No, RockSim always assumes that it's perfectly straight. RockSim Pro, which is the $1,000 version, you can make it a spin fin, but even that one, it shows them as straight, even though you can angle them. If you like the fin,
Is the fin tip always parallel to the body tube?
right now I have it as a simple trapezoid fin.
Okay.
You can make a custom fin, I'll show you that. See back here. I can select trapezoid. On this screen I can only do trapezoid and ellipses. So I can do an elliptical, change it to an elliptical. Go back to trapezoid. If you want a different shape, then you need to use custom fins. So custom fins, I'll select my body tube. My fins are still there. They're just hidden under the plus sign. So you click on the plus, you'll see your fin. Now, you can't attach another fin to a fin, but you can attach a fin to a body tube. So if I select the body tube, now I can go custom fins. And you have a choice. You have fins, which is trapezoid or elliptical. Custom fins will allow you to do any planform shape you want. Then you have ringtails and tube fins. The Estes, I think it's the Estes Neon and the tube fin. I don't know if there's any ringtails. Anybody have an example of a ringtail? Did you know what I'm talking about?
Sprite.
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 Is a ringtail.
When you do a ringtail, does the ringtail include the strut fins, or do you have to do them separately as a fin set?
Well, yeah, it adds the strut fins for you. So if you don't want them there, then it gets a little crazy.
So again, when you do
fins, like if you wanted to have 2 fin sets, one in the back and one in the front.
Okay. Well, that's what I'll do right now. I got 4 fins in the back. I want to add 2 in the front. I click on custom fin, and again, it goes to the database. And if you don't want it to bring up the database, uncheck it here. But it will only uncheck for that component. So it won't, if I add another custom fin, then it won't bring it up. But if I add a ringtail fin, it's still going to go to the database. It's going to go to the database of ringtail. Okay, so now you notice my screen is different. So this light blue one back here is the old fin, and now the new one is the darker one. And it gives me some points, and I can click on the points, and I can shift them around. So now it's no longer a trapezoid. And if you can just click on the screen and add more fins. You can get any shape you want, move them around. If you know the exact points, say you drew it on a piece of graph paper, and you can measure the exact points. You can do show points, and now I can change the exact measurement to be more precise.
I know this is too much to hope for, but can you scan a template in and?
No. Not yet, yeah. There's all these things that we like to add. I'm at the mercy of the programmer.
That's the $2,000 version.
Yeah. If you want to make a radius, you can select one of the points and click this button up here is the radius tool. And it will allow you to make the radius, we call it the chamfer tool, but it's a lot of radius. And it will add more points for you. This would add 10 points, but I only need 5. Hit tab, click OK. So now it made a radius right here. You can see it better down here. Zoom in. What I'm doing is I'm doing a left or right click on the keypad. It brings up a little menu. I can zoom in and then just slide it around. So now you can see the nice radius a little bit better. If I right click on it again, go to original, it goes back to the original.
Tim, on the tube fins, is it basically just using the surface area based on the length of the tube and then the diameter to be able to calculate the area like you got with the fins here?
To calculate the area, yes. To calculate the center of pressure, then it uses a little bit different calculation because now it basically uses the inside diameter. If you got a really thick tube, the outside's not doing anything. It's the inside that matters. radial position. If you look at the back view of the rocket, so here's our back view, and you see our rocket. If I change the radial position, it swings them around to any angle. You were asking about a 2-fin or a 4-fin rocket. So if I go back here to make it a 2-fin rocket, see, now that radial position matters. If I go back up to 0 degrees, hit tab, go back to my side view. You have a side view here and a top view. So this is the top view looking down at the top of the rocket. This is the side view. And if I change the location, move it here. So that gives us a cool looking rocket.
Now, before you changed that location, you had 2 fins in the same place on the same tube. It lets you do that?
Yes. Yeah. In real life, you couldn't glue a fin onto the fin, but
Right.
RockSim doesn't care.
Would it add both of the CP, the center from the?
Yes, because it would see them as distinct fins.
So if I wanted to move those fins out and make them part of the other fin, I would have to do something. Put a fin on a pod or
Yes.
another tube, and I then put the fin on that.
Yeah. Okay, so we're getting a little bit more advanced. Do I want to keep this fin or delete it? I'll probably just delete it. Okay, so now you want to go a little bit more advanced. Let me throw an engine mount in here, and then we'll do that. So I need my body tube. I need to select the body tube because I can't attach an inside tube to a body tube. This is going to be the engine mount, and I'll just make it an 18mm engine mount. So the long blue tube is our engine mount. It's too long, so we'll adjust the length of it. And then the location. You can see there's this little box that says this is a motor mount. Whenever you make a motor mount, you have to check it. Because this is the only way RockSim can tell which component, where the motor is going to go. And it will tell me that this is an 18mm tube, so I can do 18mm motors. And you can load an engine here to check your center of gravity. When you're checking center of gravity, I always say put the biggest motor in you can. And right, that would be a C6 engine. And I really don't care about the delay, but you can put the delay in there right now. So now it loaded the engine in. Basically what it did was it moved the center of gravity back. And at this point, you can actually start launching. Okay, so basically it's telling me that it doesn't want to launch because it sees this booster over here, but there's no engine in that booster. So I'll just click OK. I'm just going to ignore it anyway. There's nothing. To get rid of that, I got to go back here and make it a 1 stage. Okay, so now I can launch. It should have remembered our starting state from before and our wind conditions. Do a flight profile, save the design. Oops, what happened? You saw the end? Yeah, end rocket. And it did launch the simulation. See that flight profile, click here, launch. There is still wind. It's blowing the wind across the screen. And it did eject because I didn't have it. I must have had it set to end the simulation when it
Did you give it a recovery?
Yeah, it doesn't have a parachute.
Oh, no, parachute, that's it.
yeah, I should have lawn dart.
Of course, yeah.
Why didn't you lawn dart?
Yeah.
Still good. There we go. That one lawn dart. Obviously, I'm saying that.
I was going to
See that? Parts flying over.
Is it possible to show velocity at the end of the rail?
Yes.
I mean, I know it is, but
Yeah. You go here to edit, you see preferences, and you go to simulation summary, and you see velocity at launch guide departure.
yeah.
You add that column to the columns displayed. So now that, here's the icon of the rocket crash. Move things over so you can see everything. We want to see velocity at launch guide departure. So when it hit the top of the rail, we were going at 54 feet per second. And you want that to be at least 30 feet per second for a stable flight. That comes from 50 years of NAR experience. RockSim can't calculate the minimum safe speed. It gets really tricky, but it can, as long as you're above 30 feet per second or 30 miles per hour, you're okay. They're pretty close.
Sam, where would you add nose cone weight?
You go here to design components, so you want to add the weight to the nose cone. So then you just click, so I have to select the nose cone first, and then mass object. Mass object is any piece of the rocket that doesn't have a defined shape. So again, it brings up the database, I don't care about that. I just want to add weight, so you want to add, I don't know, an ounce of clay. So it puts an M here on the nose, I don't know if you can see it. So right now the mass is at the very tip of the nose.
Okay.
And you want to move that back, so then you just go to the location and just slide it back to a more predictable location. And you can see the center of gravity moved. Okay, so now we wanted to add a fin on a fin. Time's almost up. Okay, so you can add a pod. A pod is anything on the external part of the rocket. So you can add a pod to the fin. Okay, so basically what this is telling me is there's 3 fins here, and it doesn't know which fin the pod is going to go on. So it wants to split the fins up into separate fins. And I'm going to say yes, go ahead and let it do it. So if you go back here on the screen, now I got 3 fins, and it's attaching it to the first one. So I'm going to just say, okay, add the pod, and now we can attach something to that pod. So now I can attach a fin to that fin. So right now, one of these fins it's going to attach, I can't see it. Root cord length is making 2 inches so you can see it. Tip cord 2 inches, it's going to be a square. I want to just see it first. I think it's attached to that one. So let's see if it's in this view. 4 fins. So one of these is the fin. I'm not sure which one.
Does it know how it's oriented? Could it be a fin within a fin right now? How do you rotate it out of plane?
Radial position. It's not seeing it.
Go 3 Gs.
Fin span must be greater than 0. Oh, that's why I couldn't see it. Oops. Oh, there we go. So there's my fin. Fin attached to a fin. If I go to a side view, it looks a little weird.
Okay, so let me, just so I can understand what you've just done, you basically put a zero diameter pod and
Yep.
attached the fins to that pod?
The pod is just a point.
It's just a placeholder?
Yeah. It allows you to attach parts to parts. So there's my fin.
Now, if you wanted an actual pod there, you could just give it a non-zero diameter.
For an actual pod, I would use a tube. So you add the pod, and then you add the tube to the pod.
Oh, okay, I see.
So there's my fin-on-fin, radial position. So let's go back to our base view. See, it's spinning around like a pinwheel right now.
That would be cool.
You make it two fins. This is typically like a T-tail on an airplane. So you get it like that.
But propellers on the ends of the fence, now that's one I haven't seen.
3D view. So you can see what it looks like.
That's interesting.
You can see the center pressure move back because it is, and then you can launch it again. So that's how you do a pod, and you can do all kinds of weird things with pods. Some of the designs in the database, there was the SEMROCK orbital transport.
That's how I ended up with number 2 space arc. Maybe the fin, it's actually the bottom.
Yeah.
Pod, just 2 fins, just barely.
Connected, that's a good idea. SEMROCK, let's see what that is, just an orbital transport. Tell me if you see it.
You went by it.
Did I went by it? Because I did that one myself. I thought I put it in a database. But that has a lot of pods on pods. It gets really complicated. And that's why I tell people, change the color of your parts. So you can tell them apart. All right, so I'm almost out of time. Is there anything else you want to see? Question?
Tim, could you address the best way to do mass overrides? Third component by component, when you do an overall, how does it work?
There's an article in our newsletter database section that describes this better, and I would point you to that. But basically, there's 3 ways of doing it. You could change the overall mass of the rocket, right here in the main screen, mass override. Say you actually measured the rocket. You built the rocket, you measured it, and found out where the center of gravity is. So you could do that. Basically, it changes RockSim everything to a point mass. And the effect is it changes the moment of inertia of the rocket, so that's going to change the trajectory. The next way to do it is to, as you're designing components, or what we said over here, we added nose weight. So you build your rocket, you add the nose weight. So then you add the nose weight, and that changes the moment of inertia. And then you could go into each part and adjust each part. You can either adjust the materials and the thickness of the part, like you can change the material of the nose cone to polystyrene and then change the diameter or the thickness of the wall thickness, and that changes the moment of inertia. Or you could do a mass override on the nose cone. So which is more accurate? The most accurate one is to change the component, change the mat, change the material, and then change the thickness to match what is actual, because that has the best moment of inertia. RockSim uses that to calculate the trajectory.
Is there like a consider paint setting? Is there a way to distribute the mass of paint over the exterior surface area?
I would use the mass override at the component level. So we added a mass override.
Add paint mass to each part.
You could add paint mass to each part. It's the best way to do it. But it's very tedious, so I would just at the very end just add whatever thickness of paint you think it is. You know, paint's going to add probably about between 1 to 8 grams, depending on a small rocket. On a big rocket, it's going to be more. Paint is really hard to figure out.
On the flight events, if I'm doing a dual deploy, it'll have 2 lines on there. How do I know which line goes to which parachute or which drogue?
That's the other thing about naming parts. Everything, you know, parachute is parachute. But to tell them apart, as you're creating the parachute, make one drogue parachute, one main parachute. Now you can tell them apart in your events. And then you can say, oh, this is my drogue parachute. set that one to deploy at Apogee, and then if the main parachute deploy at whatever altitude you want. Good question. Didn't get to show everything. Any last questions?
On your nose cone, if you chop the back off of it, it will think that it's still there.
Or if you're making like a transition?
Well, if you want to put like an altimeter up in your nose cone, you cut the base off of it, so you can slide it up in there.
I would go to the shoulder part and just remove the shoulder. Whatever length you, because
but the shoulder would still be there. It's just that the base of the shoulder.
Remove it, put a couple of. Yeah, you can't. RockSim thinks there's a bottom there.
Yeah, that's what I thought.
Yeah,
It's always closed.
But you just the basic for the simulation purposes, you just want to make sure that the mass is right.
Because sometimes when I build small rockets, it has a glue-on base on the nose cone. Well, I put that on the back and make a little bay in there for my altimeter. And I glue that on the back of the.
This is a simulation.
Yeah, I know.
You want it to, and I want the same thing. You want it to look exactly like what your rocket looks like. And it can't. Sometimes it can't do it. Thank you all for coming.